Next one is automatic transaxle control relay. Power is supplied to each solenoid valve, as TCM controls the negative terminal. If the ignition key is on, automatic transaxle control relay turns on at the same time. While a failsafe function, the automatic transaxle control relay is deactivated by the TCM, and all solenoid valves are turned off, making a third speed hold condition. If the control relay is disconnected or damaged, power supply to the solenoid valves is cut off and the failsafe mode is on. Next is the explanation of HIVEC control logic. In this next chapter, let us explain the contents and functions of HIVEC control logic. First one is an explanation of the contents of HIVEC control logic. HIVEC has the adaptive function to modify the gear position as the driver wants by receiving the signals of throttle position sensor and brakes, etc. Besides, it decides the sporty degree of driver by learning the degree of engine load and tire load, etc. The low emission shift pattern is to make the engine temperature go up rapidly to reduce the emission gas. If the engine temperature is below 35 degrees centigrade with the ignition on, the shifting timing is more delayed than that of the standard shift pattern for 100 seconds to enlarge the low shift range. When a vehicle drives uphill in third or fourth speed for a long time, torque converter slip increases, and the oil temperature also goes up rapidly. The variable shift pattern for the automatic transaxle temperature control is to prevent an oil temperature increase. Fourth speed is disengaged, and second to third upshift and third to second downshift are made. To perform the variable shift pattern of the automatic transaxle fluid temperature control, following conditions are satisfied. Third or fourth speed, D range or 3 range. Temperature of automatic transaxle fluid is above 125 degrees centigrade. Output shaft speed is more than 600 RPM and less than 2010 RPM. If the automatic transaxle fluid temperature is lower than minus 29 degrees centigrade, viscosity and performance of the automatic transaxle fluid goes down. The hyper-low temperature mode performs a second gear hold function. Now, let us explain HIVEC function. HIVEC has 4 major functions as follows. Downhill downshift function, downhill downshift adaptive control function. Variable shift pattern control function depends on the sporty degree. Uphill upshift prevention. Downhill downshift function performs a downshift to operate an engine brake according to the data, such as the slope of the road, braking force, and vehicle speed through a neural network. Downhill downshift adaptive control function means learning the operation condition by reading if the engine brake amount is low or excessive from the throttle control and the braking. So, it enhances the driver-friendly downshift on the downhill. Variable shift pattern control depends on the sporty degree, means that shift pattern is continuously transferred to fit the sporty degree of the driver. Uphill upshift prevention functions to prevent an unnecessary upshift by the lift foot when driving uphill. Since upshift line moves continuously from the low-speed range to the high-speed range depending on the slope, unnecessary upshift is prevented. Following is an explanation on the condition of high-vec prevention. When the automatic transaxle fluid temperature is below 40 degrees centigrade. When transaxle range switch is in P, R, N, L. When standard shift pattern is not used, in other words, any of the following mode is applied: hold mode or hyper-low temperature mode, variable shift pattern for automatic transaxle fluid, temperature control, low emission shift pattern are the case. Third or second speed hold is applied by a fail-safe function. When throttle position sensor is open or short. When the automatic transaxle fluid temperature sensor is short. When the communication line with ECM is open, high-vec control is prohibited until the ignition key turns off for the above-mentioned cases. When high-vec mode F is displayed on the current data on the high scan, it means that high-vec control is not applied. High-vec mode means the shift pattern control according to the driving modes. In mode A, gear shift pattern depends on the vehicle speed and throttle opening on a smooth road or uphill. Shift pattern moves depending on the sporty degree, slope, and deceleration by the brake. Mode B is applied to a 5-speed automatic transaxle, only to get the engine brake by downshifting to 4th speed, and holding it while driving 5th speed on a gentle downslope. Mode C is to get the engine brake by downshifting from the 4th speed to the 3rd speed and holding it while driving on a gentle downslope. Mode D is to get the engine brake by downshifting to the 2nd speed and holding it while driving on a steep downslope. And lastly, let us explain about diagnosis. Now, troubleshooting and trouble codes will be explained. Following are the fail-safe conditions by the diagnosis. Output shaft speed sensor short or open. Input shaft speed sensor short or open. Solenoid valve short or open, including damper clutch control solenoid valve. Automatic transaxle control relay short or open. Incorrect gear ratio of each gear. The trouble code regarding an input shaft speed sensor is displayed when the following conditions are met. While driving in D range. When the vehicle speed is above 30 kilometers per hour. When the pulse is not detected for more than 1 second. In 3rd speed gear with the RPM of 2600 or more. The trouble code of output shaft speed sensor is displayed when the following conditions are met. While driving in D range. When the vehicle speed is above 30 kilometers per hour. When the pulse is less than 50% of vehicle speed sensor for more than 1 second. In 3rd speed gear with the RPM of 2600 or more. By the way, the trouble code of incorrect gear ratio is displayed when the difference between theoretical and actual output speed is more than 200 RPM. Theoretical output speed is calculated by the gear ratio of each gear. Different trouble codes are displayed by the gear ratios from the first speed to the fifth speed. If any of these codes is output, check the solenoid valve of the corresponding gear first. See if any abnormal operation of oil pressure and slip. There are two types of codes for automatic transaxle fluid temperature sensor trouble. One is a short to ground, and the other is a sensor open. Following are the display conditions for each problem. First, the trouble code for the sensor open. Even though the vehicle has been driven for about 10 minutes at 2,000 RPM to warm up the vehicle, but the automatic transaxle fluid temperature sensor output is over 4.57 volts, the sensor connection is poor, and sensor open is displayed. Short to ground trouble code of the automatic transaxle fluid temperature sensor is displayed. If the detected sensor output voltage goes down under 0.49 volts for more than 1 second, that is to say, TCM decides the automatic transaxle fluid temperature is excessively hot, regardless of the engine RPM. In case of a sensor open or short to ground, TCM inhibits the adaptive control and the high-vec control ignition off, and regards the automatic transaxle fluid temperature as 80 degrees centigrade. Even while the fail-safe is operating, the shifting between third and second speed is available by the shift lever operation. Sports mode vehicle can be upshifted and downshifted by hand in this case. In case of sports mode vehicle, current data on the mode switch, upshift switch, and downshift switch can be seen on the high scan. Note the fact that there is no trouble code for the mode switch. When this switch is broken, sports mode control cannot be performed. In this video consists of introduction, valve body, and hydraulic pressure control. Let's begin with the introduction. In this chapter, we learn about the oil pressure control system components of high-vec automatic transaxle, in addition to oil pressure control and hydraulic circuit at each shift. First one is an explanation on system components. In 4-speed automatic transaxle, the number of solenoid valves used for the oil pressure control of high-vec automatic transaxle are 5 and 6 for 5-speed. These valves are overdrive solenoid valve, underdrive solenoid valve, low and reverse brake solenoid valve, second brake solenoid valve, and damper clutch control solenoid valve, and the reduction brake is applied only for 5-speed. No solenoid valve is needed for the reverse clutch, which is the operating element for reverse driving. Oil pressure is supplied to the reverse clutch from the manual valve, not passing any additional pressure regulator valve. There are 2 operational elements in sub-transaxle of 5-speed automatic transaxle, and these are direct clutch and reduction brake. Since direct clutch uses the same solenoid valve with low and reverse brake, additional solenoid valve for direct clutch is not required, and only solenoid valve for reduction brake is added. Frequency of solenoid valve is approximately 62 Hz and is controlled by TCM. However, the frequency of the damper clutch control solenoid valve is adjusted to be 35 Hz. The line pressure of high-VEC automatic transaxle is applied only 30% of first speed and second speed oil pressure in park and neutral range. And in high-speed range of third or fourth speed, only 60% of first and second speed oil pressure is applied. Especially when line pressure decreases in third and fourth speed, oil passage changes by the switch valve. Then, oil pressure decreases due to the regulator valve operation. In 5-speed automatic transaxle, line pressure is lower than low-speed gear, even in the 5th speed. Line pressure is adjustable both for 4 and 5 speed, using the adjustment nut at the end of the regulator valve. Approximately, pressure of 0.4 kilogram force per centimeter squared changes per rotation of adjustment nut. Ports for second brake, underdrive clutch, and low and reverse brake are installed at the transaxle case of 4-speed and 5-speed high-VEC automatic transaxle. Ports are also applied at the torque converter housing in order to measure the oil pressure of damper clutch apply and damper clutch release respectively. Ports are applied at the rear cover in order to measure the oil pressure of the overdrive clutch and reverse clutch respectively. In 5-speed automatic transaxle, additional port is applied at the transaxle case to measure the oil pressure of reduction brake and direct clutch of sub-transaxle. Since the pitch and diameter of this port is bigger than that of others, note that extra gauge adapter is needed. Now let us explain about the hydraulic circuit. With the use of hydraulic circuit, the power flow to the operating element of each gear can be easily understood. Basically, hydraulic circuit of high-VEC automatic transaxle is controlled independently by clutches. Low and reverse brake operates in park and neutral. Oil pressure generated from the oil pump, which is adjusted in regulator valve, is supplied to low and reverse brake via the low and reverse pressure control valve, switch valve, and fail-safe valve A. Oil pressure is supplied through low and reverse accumulator. Oil pressure is approximately 3.5 kilograms force centimeters until vehicle speed of 5 kilometers per hour by the regulator valve operation. In first gear, with a speed of 5 kilometers per hour or less, underdrive clutch and low and reverse brake operates. However, for the smooth control of N to D shock, low and reverse brake has already been operated in neutral. Therefore, underdrive clutch mainly influences on the oil pressure flow. In the high-VEC automatic transaxle, in which sports mode is not adopted, there are another 3 driving ranges, except D range, regardless of 4-speed or 5-speed. Since the position of manual valve remains the same position in all forward driving ranges, the oil pressure flow from manual valve to underdrive clutch remains constant regardless of speed. Oil pressure is supplied to underdrive pressure control valve from manual valve. Then it passes through the underdrive accumulator without passing fail-safe valve and goes to underdrive clutch directly. Since variable line pressure is applied according to the gear position, oil pressure to the underdrive clutch is always adjusted by regulator valve operation. The oil pressure of low and reverse brake increases to 10.5 kilogram force per centimeter squared from 3.5 kilogram force per centimeter squared when D range is selected from N range. On the other hand, oil pressure of underdrive clutch increases from 0 to 10.5 kilogram force per centimeter squared. Therefore, check the related flow path and parts of underdrive clutch of oil pressure equipment first. If shifting shock or time lag is occurred when shifting from N to D. In second speed gear, underdrive clutch and second brake are operating elements. Underdrive clutch operation is maintained until it reaches third speed during forward driving. This is how the second brake works. Oil pressure generated from the oil pump is adjusted by the regulator valve. Then it passes second brake pressure control valve and fail-safe valve B and supplied to the second brake through the second brake accumulator. In third speed gear, underdrive clutch and overdrive clutch are operating elements. Underdrive clutch operation is maintained until third speed during forward driving. This is how the overdrive clutch works. Oil pressure generated from the oil pump is adjusted by regulator valve. Then it is supplied to operating element overdrive clutch through the overdrive clutch pressure control valve and overdrive clutch accumulator. As shown in the figure, flow path of overdrive clutch is connected with the left oil pressure chamber of switch valve. As the switch valve moves, the flow path of regulator valve changes too, allowing the variable line pressure. So, the line pressure of third speed gear decreases relatively. This is why there is only one spring in overdrive clutch accumulator. Second brake and overdrive clutch are operating elements in fourth speed gear. Oil pressure flow of overdrive clutch is continuously maintained at third speed gear. And oil pressure flow of second brake is the same with that of second speed gear in fourth gear. Oil pressure generated from the oil pump is adjusted by the regulator valve. Then it is supplied to clutch and brake through the overdrive clutch pressure control valve and second brake pressure control valve, respectively. Reverse clutch and low and reverse brake are operating elements for moving backwards. Oil pressure flow to the reverse clutch is mechanically set with a position of manual valve R range. There is no extra pressure control valve nor solenoid valve for reverse clutch.
فراموش نکنید که توی کانال سابسکرایب کنید، زنگوله رو به صدا در بیارید و کانال رو با دیگر دوستانتون به اشتراک بذارید. تا ویدیوی بعدی، روزگار خوش.